Good afternoon. My name is Renteria. I am in grade 11 from Pioneer High School located in Whittier. My science fair project for this year is it possible for a car to drive and solve a maze based off of conditionals? My initial hypothesis was why should people drive by hand when computers can do it better? I was thinking of all the people who cause crashes due to the human aspect of the uncertainty. Then I revised and wondered what makes a self-driving car a self-driving car. And there I realized I wanted to make a car that goes around objects like a modern self-driving car. The purpose is to help people better understand what a car is. I started by doing the track and building a layout with cardboard. This track is only one exit to help the car go around the objects. When making the car, I searched for ideas online and made the car based off an idea from Philcast. After making the car, I worked around on the code to drive around the gaps. After making the car work around the track, I realized that a self-driving car is an idea great in helping others if coded properly to help disabled or impaired people to move from place to place. What I learned from this car is a car can go around every object, and when it's too far back up to meet the gap that is passed due to hard conditionals that I learned from coding techniques. The only problem is that it doesn't look as if it were 3D rather than a 2D line. At the end of the research, I realized this car idea would be possible to perfect for real life if people would never take advantages or find loopholes in the system. Procedure. The car is made up of Legos to keep the idea with the car fairly simple and compatible with most devices that carry a Bluetooth signal. This car works with the software that was designed by Lego that communicates to the car and tells the car what is asked by from the user. It is up to the user to choose what the car to do. If the user puts in a set of instructions that is not changeable to the environment, this set of instructions is called a hard set of code. Where the car does not where the car does what the teller uses it and no more or no less. If the user puts in a set of instructions that change based on variables that are given from the car back to the code, that code is a conditional, and that is what this car is made of. A good way to an example is on the bottom left is an if else is a conditional. The code that I use is an if, which is a part of a conditional. This way, the car sees if through essential depth sensors that are attached to the car so that the car can read distance and space between the walls. By having the car use conditionals instead of hard code, it is not the user who is putting in a line of code based off what they see, but a code that is changeable to the environment of what the car sees. Like the new Teslas that come out, when researching, I found out a Tesla to be a key example in how cars with sensors are able to react to their settings, not the user. The car with all its information then goes around the walls, moves to the end without crashing with the car deciding when to turn. The materials I used was cardboard to first set up the track with tape and pins. The second material used was in the car Legos and a big Lego EV3 brick to keep the connection between the computer and the Lego sensors. Part 3 was the code after the program was based off and when there was an opening in the track to follow the entrance to get out. This was done by having the code having a quote-unquote if space is open move to gap code and easily moved around to fit or continue its course. The results were the car drives around the items after analyzing the code, the road is clear on its side. The only problem is due to its sensors not having a 3D view. The car only views the world as if when the gap comes that is entered just to continue the code and just follows without a map of what the true world is around it.